my name is Katia Correa. I'm from Mexico, and this is my submission for the Breakthrough Junior Challenge. I'm going to be talking about the Pythagorean theorem, so let's begin. As we go on, here's a few things to keep in mind. For our theorem to work, we need a right triangle. This means that our triangle must have a 90-degree angle. Also, the largest side of the triangle is called a hypotenuse, and the other two smaller ones are called legs. Now that we have these basic key points, we need to know exactly what the Pythagorean theorem is. So its formal definition would be, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In the formula that you can see on the screen, it's represented as square of A plus square of B equals square of C. Now, we have our formula and our type of triangle, so if we put them together, it is much easier to visualize what the theorem represents. Now, we just learned what the Pythagorean theorem is, but what do we use it for? Well, the answer is simple. We use the theorem when we're looking for the third side of a right triangle. That is, when we have two sides of the triangle but are missing the third. Notice that if you're missing two sides of the triangle, you cannot use this method unless it's an isosceles triangle where two of the sides are equal. Now you know everything you need to know to start making exercises. So let's go to our first. Imagine you're in your living room watching TV when this comes up.
I'm going to step off the limb. That's one small step for man, one giant leap for mankind.
So now this catches your attention and you turn directly towards the TV. You realize it's a documentary about the moon landing in 1969. So let's say if we make a line between your eyes and the feet of the astronaut, it would be a parallel line with the floor. Now let's say that that distance between the TV and yourself is 120 centimeters long, and the astronaut is 60 centimeters long on your TV. So we have two sides of our new triangle, and what we're trying to find is the distance between your eyes and the top of the astronaut that would be above his helmet. So your eyes and the feet of the astronaut are parallel to the floor, and let's assume that the TV is parallel to the wall as well, creating a 90-degree angle between both lines. So we have a 90-degree angle and we have two legs. So we are ready to apply the Pythagorean theorem to get the length of the hypotenuse. So let's zoom out so that we can do the procedure and apply the formula. Here we have our formula, which is square of A plus square of B equals square of C. We know that A is 60 centimeters long, B is 120, and we're trying to find C. Our first step will be to get the squares of A and B. So A times A equals 3,600 square centimeters, and B times B equals 14,400 square centimeters. What we're going to do is add 3,600 centimeters square plus 14,400 square centimeters, which give us 1,800 square centimeters. So we know that square C equals 1,800 square centimeters. So to get C, we have to get the square root of 1,800 centimeters, which would be 134.16 centimeters. So now we have the length of C, which is our hypotenuse. So through the method, we managed to get our missing side. Our following exercise is concerning architecture.
It was the Atza who built the city's most famous building, a pyramid the Spanish called El Castillo, or the castle. This 79-foot pyramid has a total of 365 steps, the same number as the days in a solar year.
El Castillo is part of the lost empire of Chichen Itza. It has a lot of geometrical qualities, which is why it's our next example. So here we can see that the base of our triangle is approximately 12.6 meters long, and our hypotenuse is 24 meters long. In this case, we're trying to find the leg instead of the hypotenuse. So let's begin. But before we do that, our triangle does not look like a right triangle, does it? But that's all about perspective. If we turn ourselves or change the picture in this case, we can see that it is indeed a right triangle. So let's begin with our formula. We know that it's square of A plus square of B equals square of C. But in this case, we're looking for the square of A. So we're going to get square of A equals square of C minus square of B. Now we know that B equals 12.6 meters and C equals 24 meters. Our next step will be to get the square of B and C. So the square of B is 158.76 square meters, and the square of C is 576 square meters. What we're going to do is we're going to take 158.76 from 576. That would be 417.24 square meters. And that means that A equals the square root of 417.24 square meters. And the square root of 417.24 square meters equals 20.43 meters. So that's our left leg, which is A. And this way we can notice that we don't only need to find the hypotenuse sometimes, but also the legs. Before we finish this video, it's important to point out that we can find this theorem practically everywhere. It's in construction, engineering, architecture, design, art, and so much more. We can even find it in our own shadows. So keep in mind that math is everywhere, even where we don't expect to see it.